This is lesson 3.1 for Pre-Cal 11, starting on page 93. We're talking about factoring and applications of factoring, and we're going to start with a review of factoring that you learned in grade 10. So, two things to know about factoring. So, the two things are, when you factor a polynomial, you always fully factor. You don't just factor it part ways, like going to prime factors. And second thing is that when you're factoring, you're only changing the shape of the number or expression. You change what it's looking like, but what you have before has to equal what you have after. You don't lose anything. And that's really, really important. You can always multiply out again what your factored form, and it will end up with what you started with. Okay, or it should. It better. Okay. Okay. We are going to review these three ways of factoring that we have done in the past. Factoring out a common factor, factoring a difference of squares, and my favorite, factoring by inspection, which basically means you just look at it and know. And I don't know why they call it that, because I don't look at it and know, but that's usually what they mean with by inspection. But I will show you, there's a strategy for it, and we'll review that. Okay. All right, let's start with doing some factoring by removing the greatest common factor. So if I look at these two terms, I can see that they both are multiples of 5x squared. So I can multiply this by, factor out the 5x squared, and I'm left with 3x minus 1. Because if I multiply 5x squared times 3x, I get 15x cubed, and 5x squared times minus 1 gets me minus 5x squared. I do want to just show you a little thing over here that if you do this by dividing, you learn to divide polynomials in grade 9. And if I divide this by 5x squared and I divide that by 5x squared, I get 3x minus 1. And this can be a useful strategy for factoring things if dividing it, if you can't divide it in your head by looking at it, then this is a really good strategy. But be careful that you don't forget about the 5x squared, because 3x1 can't be your answer, because that clearly doesn't equal 15x cubed minus 5x squared. You have to put that part in brackets and put the 5x squared usually out in front, okay? So just be careful of that. That's all. All right, example B, I can see a common factor of 4. So I'm going to make this 4 times 2p cubed minus p squared minus 1. And again, I need that 1 because I have to multiply the 4 by something to have that constant term there, okay? Okay, now we're going to do the difference of squares method. So if you remember the difference of squares, if we have, for example, a plus b times a minus b, if I FOIL that out, I get a squared minus ab plus ab minus b squared. And the minus ab plus ab, that just equals 0, so I end up with a squared minus b squared. So what this means is that if I'm trying to factor something that is a perfect square minus another perfect square, it comes out looking like this. So that's what I have here. I've got a perfect square minus another perfect square. So when I factor it, I get the square root of the first one plus the square root of the second term times the square root of the first one minus the square root of the second one. Okay. It doesn't matter if you do the plus or minus first. I always do the plus first because sometimes you end up with a second difference of squares here, and it's just easier to factor that out and extend it out. It works better on my paper, so that's how I do it. This one is the same thing. I've got a perfect square here and a perfect square here. So square root of 25a squared is 5a plus square root of 49 is 7. And then I do the same thing, 5a minus 7, and I'm done. This one, nope, can't do this one. It is not a difference, right? This is a sum. So you can't do that. There's no way to factor that unless there's a greatest common factor, which there is not. This one is interesting because there are two different ways to do this. And one, I mean, they both get the same answer, but one is probably better than the other. So this is a perfect square. This is a perfect square. So we might jump right to difference of squares. So in that case, this is going to be 4t minus 8 or plus. I'll try to be consistent. So it's 4t plus 8 times 4t minus 8. The problem is these are not fully factored, right? I can factor a 4 out of both of those. So I have to do that. So this becomes 4 times t plus 2 times 4 times t minus 2. And then if I multiply the 4's together, I get 16 times t plus 2 times t minus 2. And I'm finished now because that's as far as I can factor. So you always check to see whenever you get down to your last answer. Just double check to see if anything else can be factored. But we can actually make this a little bit easier by coming back here and taking out the common factor because both of these are multiples of 16. So if I take the 16 out first, I get t squared minus 4, which is 16 times t plus 2 times t minus 2. Doesn't really matter. You get the same answer anyway. I just see so many people forget to continue factoring out the 4 here. So this is probably a more reliable strategy, but you get the same answer anyway, so do what works for you. Okay, where possible, factor by inspection. So factor by inspection is actually where you look for the product and the sum. Okay, so I'm going to do this one. The product is 30. The product is always the constant term. Okay, so I'll just color that in blue. And the sum is the coefficient of the like the middle term or the, I don't like to call it the middle term because it doesn't, I mean, we could write these in any order, but it's the one with the a, it's not the a squared. So it's not the squared term, it's just the single factor term. So my sum in this case is plus 11, and I just write 11. So what I'm looking for now is two numbers that if I multiply them together, two integers specifically, if I multiply them together, I get 30, and if I add them, I get 11. So I do this systematically, unless the answer just jumps right out at me. I do this systematically because I remember sitting in class or in tests with two numbers or two pairs of numbers spinning in my brain and I can't get past them because those are the ones that I'm stuck with. So this, and it's not one of the, neither of those works, and I need to find something else. So if you have a systematic way, you won't ever have to get stuck like that. So what I do is I go 1 times what equals 30? Well, 1 times 30 equals 30. 2 times what equals 30? 15. 3 times what equals 30? That's 10. 4 times what equals 30? Well, that actually doesn't work. So I'm just going to cross that out. But I write it down anyway so that I know that it doesn't exist. And then I go 5. 5 times what is 30? Well, 5 times 6 is 30. The next number that I would write down would be 6. But I already have 6. So I'm done. As soon as I get to the bottom of this where the next number I write is going to be a number I've already written, or actually if I get to the square root of it, but if you see that, that's great. I'm done because the only other factors are going to be these ones that I already have listed. So those are all the possibilities. So at this point, I can look at this and I can go, well, if I add these two together, I get 11. So those are my factors that I need. And then my answer is just a plus 5 times a plus 6 because these were both positives. Okay, that's that. Now let's do this one over here. This time my product is negative 30 and my sum is negative 1 because remember there's a negative, there's a 1 in there, and I'll just highlight the colors so you see where they came from. Okay. So this time I can be I know since my product is negative, my my two factors are going to be different signs. And since my sum is positive, I know that my positive factor is going to be smaller than my negative factor because I'm going to have more negatives. That's how I get the negative sum. Okay. And since I always start with the smaller factor, it means my second column is going to be negative. So I have um, I have 1 and negative 30. That doesn't get me a sum of 1. I have 2 and negative 15. I have 3 and negative 10. I have 4. Doesn't work. I have 5 and negative 6. And oh, hey, that works. That gets me a sum of negative 1. So it's again just b plus one of my first term, and then b, well, minus because the term is minus, so it's minus the 6. Okay. All right. This time, because my constant term is positive, that means that my two terms have the same sign. And then because the sum is negative, they're both going to be negative. So my list is going to start, well, I do right product is 48. Sum is negative 4 because that's what I'm looking for. And then I'm going to go minus 1 minus 48. Minus 2, minus 24, minus 3, minus 16, minus 4, minus 12, minus 5. That doesn't work. Minus 6 gets me minus 8. The next one I would try is negative 7. That doesn't work. The next one would be negative 8. So one of these has to work if anything is going to work. And none of them work. So this one is actually not possible. But I know that because I have listed every possible combination of two factors that get me a product of 48, and none of them work, so I can't do it. All right. This one, the last example on this page, is I actually have a common factor that I can pull out first. So I can factor out the 3, actually, sorry, it's 3x, and then I have x squared minus 7x plus 12. And then I've got a product of 12 and a sum of negative 7. So they're both going to be negative. So negative 1, negative 12, negative 2, negative 6, negative 3, negative 4. Oh, that one works. So I still have my 3x, and I have x minus 3 times x minus 4. And I think that it's always a good idea to FOIL these out again, to multiply them out again. It's quick. It's something that you want to be really good at, and you want to make sure that your answer is right. So it doesn't take long to, take a piece of scrap paper or whatever and just FOIL it out and make sure you're getting what you think you're getting, okay? I do think that's a good idea. All right. This page, there's not much writing on this page. This is just a summary of the order that you want to do things in. So first thing you always do is look for a common factor. Just keeps the rest of your numbers small. If it's binomial, meaning there's two terms, you're going to look for a difference of squares. If it's a trinomial of the form x squared, so this x squared, this means that the coefficient here is 1. And that's what we have been, that's the only kind you've learned so far, is when the coefficient is 1. The second one is a coefficient of something other than 1. Oh, I should put that of 1. This has got a coefficient other than 1. We will learn that later this unit. And if the polynomial has 4 terms, we're going to look at factoring by grouping, which we will do next lesson. And always check to see if you can factor further. A bit of a flow chart for you. And I'm just going to highlight this. Always check to see if you can factor further. Just like when you reduce a fraction. You might see that you can reduce a fraction by this over this, but you always check to see if you can do it any further after that. Okay? All right, only 2 more examples and we're finished this lesson. So factoring this one. It's in a different order. It's got the x squared last, but it doesn't really matter because it's a difference. Oh, I can factor out a 9. So let's factor out a 9. So that leaves me with 4 minus x squared. And then this is the difference of squares, so I have 9 times 2 plus x times 2 minus x. Okay. There's actually another way you could factor that. You could factor out a -9 like this, and then you would have -4 plus x squared, which you could then write as -9 times x squared minus 4, and then you get -9x plus 2x minus 2. And these are actually equivalent, which we'll see in just a minute when we do this other example here. Okay, so looking at this one, it's kind of icky. It doesn't look familiar. They're in the wrong order. So the first thing I'm going to do is reorder them. So I'm going to make this -x squared plus 3x minus 28. And I don't actually know how to do this with a negative x because the coefficient is not 1. So let's factor out the -1. Okay, so if I factor out a -1, I get -1 times x squared minus 3x plus 28. And then I'm going to have a product of 28, and my sum is -3. So I got 1, -28, 2, -14, 3, doesn't work, 4, -7. Oh, that works. If I get to something that works, I can stop right there. I don't need to do the 5 and the 6 to see if they work. I can stop as soon as I get there. So this is going to be -1 times x plus 4 times x minus 7. But we don't usually factor it like this. We usually don't want that -1 out front. So I'm going to put it back in, and I'm actually going to multiply it into this second term. So I'm going to have x plus 4 times -1 times x is -x, and -1 times -7 is +7. And that equals x plus 4 times 7 minus x is usually how we'd write that, or I might even go 4 plus x times 7 minus x, because that is, now it sort of looks more like this, like the 4 times 7 is the 28, and the x times -x is the x squared. So this is probably the best version of that, but this one is fine as well. Okay. Actually, this one is okay too. I wouldn't recommend this one actually because of what's coming later in the unit. You don't want to have that. You want to have a coefficient. I guess it doesn't matter. No, this is fine too. But let's look at another way of doing this. I could look at this, and since this is my constant term, I know that my product is going to be 28, and I know that my sum is going to be 3. It's actually going to be plus or minus and plus or minus because I do have a negative here. So if I'm thinking plus or minus 3 and I start listing my factors and I've got 1, 28, well, it doesn't matter how I make plus or minus, it's not going to work. 2, 14, there's no way I get 3. 3 still doesn't work. 4, 7. Oh, I can see that 4 and 7 can somehow make 3, right? I know that if I subtract one from the other, I'm going to get plus or minus 3. So I'm just going to guess. Guess and check is a completely legitimate strategy for solving a problem. Guess is not. Guess and check is. So I'm just going to guess. I'm going to go, I think this is going to be 4 plus x times 7 minus x. And then I'm going to FOIL to check it. So I get 28 minus 4x plus 7x minus x squared, which is 28 plus 3x minus x squared. Yay, that worked. So I'm going to circle my answer. Okay, and if it didn't work, I might change where the pluses and minuses are and see what it is, or I might give up and go and do it the way that I know is going to work, even if it's a little more complicated. Okay. Okay, that is it for this lesson. Actually, there's only one video for this lesson. So go ahead and watch the video go ahead and do the practice, and then on to the next lesson. Bye.